Um, Good afternoon, everybody. Welcome. We are going to start out hearing about Project Invent with a short video.
Hi, I'm Samhita.
My name is Maximilian Chavez.
My name is Carmelita Lee.
Our product for today is for children with autism because they find it extremely hard to identify their emotions and cope with stress.
We created the Beta Band, which is essentially a headband. It reads your beta waves, which fall in between a certain low and high beta wave. And if you're outside that range, then your brain is not acting as a normal brain.
Project Invent has definitely impacted my sense of teamwork. I can collaborate a lot more with my peers, have that design thinking into mind. How can we target our users and have the best influence and the greatest impact on their lives?
Working and coding and doing all that stuff, it gave me a chance to be familiar so that I'm not as intimidated going into college. And it's actually made me a lot more excited for freshman year of college.
We've definitely opened our minds up a lot more, and we've learned how to cope with maybe our product not working and still learning from our mistakes.
Having interacted with people who are on the spectrum, young adults and little children, and seeing what they go through and understanding their experiences, and then being able to put that into a product, engineer something, and then see that truly affect them and help them.
A lot of people try and create products for people that they don't even they never even talked to before. So we had a lot of things that we thought would be good, but after talking to people who actually use wheelchairs, they were we don't have problems with that. So it just you really should talk to people and get to know them before you make assumptions about things that they struggle with.
I think the impact has been huge, and it's changed my outlook towards project-based learning and education a lot, actually. The reason is because prior to Project Invent, I focused a lot on just developing technical skills and having the students learn laser cutting, 3D printing, soldering, sort of for the sake of learning 3D printing, laser cutting, and soldering. But working with Project Invent and anchoring these technical skills to a real-world problem has really, I think, made the learning experiences more meaningful for the students so that they understand what the application is, and has helped with retention and student involvement. It's been really great.
None of these girls came into this project thinking that they were inventors or makers, or that this kind of thing was something they even wanted to do. All of them, I believe, have been radically transformed just by this idea that the world is invented, right, and designed, and that they can participate in designing that world, right? I watched them gain confidence interviewing people, really understanding and delving into design thinking and human-centered design. I watched them struggle through prototyping and then succeed and feel really empowered by that. We have 4 women here who are ready to take on the world and change the world with the invention that they're making, and this is not something that they would have even considered doing in September of this year.
It's been really amazing being able to turn a problem into a solution just through engineering. And so I think Project Invent has taught me that anything that you see out in the world, if you think there's a way that you can fix it, it's totally doable, and that there are resources out there and people out there willing to support you throughout the journey.
This is bigger than just us.
All right. Oops. Hello, everyone, and welcome to Project Invent Demo Day Eastern and Central 2023. My name is Hallie Trauger, and I'll be your MC for today. Today, you'll be hearing teams pitch coming from teams of excellent, talented, innovative high school students from around the country who have created inventions for social good. These students are incredible. Throughout this year, they have built inventions from the ground up with the goal of helping solve problems in society. These students are building the skills to save the world, and they're doing so with wonderful support and infrastructure of Project Invent, which empowers young people to innovate all year round, and today is connecting these impressive young people and the hard work they've done with deeply accomplished investors, executives, and visionaries in the tech industry. A little bit about me before we get started. I teach biotechnology and engineering at Antioch High School in Nashville, Tennessee, and I also have a PhD in physics. My role today is simply to facilitate and keep things moving so you can hear from these amazing students and accomplished panelists. Now, before we meet our judges and hear the pitches, let's get some logistics for today. This is about a 2.5-hour event, but don't worry, you can grab a snack and take a break if you need to. Once pitches begin, each team of students will present a 5-minute pitch video, followed by a 4-minute question and answer session with our panelists. At the end of the event, judges will deliberate and choose 2 teams to award. While students are present, here's a few ways to interact with the teams. Check out the features in Zoom. You can use reactions to cheer teams on and the chat to share words of encouragement. Let's test out the chat now by wishing all of our teams and students good luck. And finally, you'll notice a link to donate. Project Invent is a nonprofit organization, and the work that we do year-round to help these students ideate and incubate inventions for social good, and events like Demo Day connecting these students to industry professionals are all made possible by donors like yourself. Project Invent is able to train teachers, run today's event, and support teams because of the generosity of our community. So please consider donating. Without further ado, let's meet our panelists. Our first panelist is Rebecca Rosenberg, CEO and founder of Rebecca Vision Technologies Incorporated. Welcome, Rebecca. In a quick sentence, what are you most excited about seeing from our students today?
Hi, yeah, this is my first demo day, and I'm so excited to hear about all of the exciting new innovations that the students have come up with. My background is in biodesign, which is the application of the design thinking process to solve medical problems. And so I'm really excited to learn about how the students have worked with the design thinking process to overcome challenges and learn from their target users. And I am just really looking forward to seeing what you all have come up with today.
Awesome. Our second panelist is Dave Beardsley, head of Model Shop at Google. Welcome, Dave. In a quick sentence, what are you most excited about seeing from our students today?
Yeah, well, for me, I'm very fortunate. This is my I think my 4th time doing this, and so I am always absolutely blown away with the great stuff that the students come up with. So today, I'm just looking forward to seeing a bunch of new exciting projects.
Thank you so much. And lastly, this event is sponsored by ThoughtSpot. We're so thankful to them for helping make Demo Day possible and for providing funding for the 2 prizes that will be awarded today. Oh, I'm sorry. About that. All right. Sorry about that with the slides, but next up, we are going to meet our schools and teams. So now that you've met our panelists, it's time for the main event. Each team will have 5 minutes to pitch and 4 minutes for questions from our panelists. A quick reminder for our amazing student teams before we begin, you've already done the hard work. You've identified your problem to solve, you've designed and redesigned and redesigned, you've interviewed your users, you've spent the dozens of hours coding and building circuit boards and so much more. So now is really your time to celebrate that hard work, to show off what you've done, to advocate for your invention, to learn and grow with some of the best professionals in the industry you just met. So take a deep breath, shake off those nerves, and let's have fun with it. Let's do this. Our first pitch is WaterWatch from Athens Drive High School in Raleigh, North Carolina. And WaterWatch is an automated device that detects water contaminants in your home.
Hi, Project Invent. We're Team WaterWatch. I'm Corey.
I'm Jack.
I'm Liz. And I'm Addison.
And we're so excited to share our product with you today.
On February 3rd of 2023, there was a train derailment in East Palestine, Ohio. This was a problem for people with wells because without government intervention, they were unable to determine whether their drinking water was safe.
Another case where this issue was prominent was the DuPont and Teflon case in West Virginia, where about 400,000 pounds of harmful chemicals were put into unlined landfills, where those chemicals eventually seeped into the soil, getting into civilians' well water.
70,000 people's drinking water had been infected by this release of chemicals. Without government intervention, those using wells were unable to tell whether their water was safe or not. 1 in 8 Americans use wells, and 1 in 5 wells contain levels of contaminants that could affect human health. This means that 8.3 million Americans get their water from wells that could affect their health.
Our solution to this problem is WaterWatch.
WaterWatch is a device that attaches to the wall underneath the sink where hot and cold water intake pipes are. There are a variety of different layouts, but it will not affect our device. This is a diagram of our device. We have the motherboard, which is the brain of our system. We have the light, which allows our camera to look at the test strips. We have the valve system that controls the on and off switch to the water being tested. We have the water container where the testing water is contained. We have an adapter that attaches the intake pipes to our device. We have the intake pipe. We have a camera to detect changes in the water strip. We have strip dispenser, and we have a strip grabber. We have a strip disposal, and we have a test water disposal container. WaterWatch tests the cold water intake pipe, and this is what it looks like when it's not testing. This is what our device looks like when it is testing water.
WaterWatch currently tests for bacteria, pesticides, and metals. We decided to use the strip and camera approach because sensors for these contaminants aren't currently available. The camera, Arduino, and LED light are all battery powered to avoid having to plug into a wall, and the alert system is customizable so that you can have a light or a sound alert in case you don't have a mobile device or wireless connection. We decided to have the used testing water empty into a manual reservoir to avoid having to cut into an outtake pipe. The user will empty this tank every 2 years because by a monthly testing it draws about 1/8 of a cup. The test strip disposal container will be on a similar schedule to that of the reservoir, and test strips will need to be replaced every 5 years. The system will send an alert when it needs battery changes, test strip replacements, or for the reservoir to be emptied.
The majority of our feedback came from our community partner Simon Warren and Mr. Berry.
We found very few competitors because WaterWatch is a very unique solution to this problem. We pitted WaterWatch against these 2 solutions that we found and realized that WaterWatch stacks up pretty well. The most important feature is that WaterWatch is automated and you don't have to pay per use. For our pricing, we decided to combine the cost of all of our raw materials. We purchased an Arduino Uno motherboard for $24 from the Arduino website. We purchased an Arducam Mini for $26 from Amazon.com. We purchased a strip of LED lights for $13. We 3D printed a box for roughly $30. We purchased a ball valve for $7.81 and an intake pipe for $5.75 and a bunch of piping to go on the inside for $24.25. All 3 of those were from a hardware store. And we'd also like to include our markup costs of 50%, which, as you saw in the previous slide, brings our total up to around $250.
For next steps, we first need to obtain funding in order to begin producing WaterWatch on a scale that will be helpful to the people who need it. We then want to continue to research and innovate on WaterWatch until we can create the best version of our product that we can.
The disturbing part of this image is that without proper testing, we would be unable to determine whether either of these glasses of water were safe to drink.
WaterWatch raises awareness about contaminated water and secures a way to avoid it. With WaterWatch, you don't need to worry about what's in your water and you don't have to stress about testing it.
We'd like to give a huge thank you to Miss Luna, our Project Invent teacher, Simon Warren, our community partner, Mr. Berry, a physics teacher, Mitch Woodward from the NC Co-op, and Miss Jenny, our pitch coach.
All right. So awesome pitch video. And now we will turn it over to our judges for 4 minutes of questions and answers with Team WaterWatch.
Yeah, hi team. This is a pretty ambitious project. That's a pretty complex device. That's very, very cool. Tell me, what did you learn from your community partner that you didn't expect when you started this?
So when we first started creating our project, we wanted it to be more marketed towards everybody, but
When we spoke with Simon, our community partner, who was involved in a lot of stormwater management, he shared with us that a lot of the issues surrounding contaminated water would have to do with people who get water from their wells. And so he helped transfer our entire demographic that we were presenting our product to just to people who use wells. And that was an interesting thing to learn about.
Great job, team. I'm super impressed with your CAD skills specifically. I think you did a really awesome job. My question is, can you talk a little bit about how your product and your prototype idea changed from maybe the very beginning when you were first proposed the problem to your final prototype and product? And what did you learn along the way that informed the changes that you made?
So originally, our main idea was to have a little module that you cut away part of the pipe that goes from the water main into your house, and to replace that with this little section of pipe that would house our device that would test. But we realized that cutting into water main pipes it's actually a really difficult process because it's hard to get the water flow to your house shut off. We also learned a lot about how water enters and circulates throughout houses. And so with that, our next iteration was to create little modules that you can put under your sink faucet that would test the water as it comes out. But we weren't able to figure out a way that we could implement all of the testing that we wanted to do in such a small little device. So finally, we settled on having it placed under the sink, mounted to the wall, and having you run your intake pipes through it so that it can siphon off of the intake or the water that's being sent to your sink.
Thank you, guys.
Do you guys have a fully functioning prototype? I saw in the video the stick dipping the water strip, the tester strip, but on your CAD stuff looks pretty good. Did you build the whole thing?
So we unfortunately didn't have enough time to get a working model done, but we did, as you saw, have a model of the mechanism that's going to pick up test strips and dip them into water. And we also have this example that you also saw in the video of the water flow module. Obviously, this is built on a much larger scale to make it easier to see, but we had a little device that would automatically change this with a timer. And then, though we don't have a working scale model, we made a bit of a scaled down model out of paper products. And so it's got all of the features. It's got the door, the disposal unit, the camera, and the piping inside. And so we do know what we want the product to look like. It's just that we weren't given enough time to really make our idea go into the physical world.
Got it. Looks great. Looks great, guys.
So it looks like from your pitch that you're using a camera to look at the test strip. Can you tell me a little bit about what happens after that? Is there some software that will read the test strip? Tell me a little bit about how that either does work or how you're planning to have that work.
So we plan to have most likely some form of neural networking that is able to determine the color, or it'll be pre-programmed with the colors to look for of a positive test. And we'll also have it programmed to have that against the background of whatever model it's being placed in. So it won't cause any accidental negatives. Hopefully the inside, it'll be properly colored so that it sticks out against the background. And so once that's done, the image will be processed. And of course, it'll be properly illuminated because we'll have an LED light in there. And once that's done, it'll be processed by the network. And if it detects the color of a positive test, it'll send an alert to the user.
All right. So thank you. That is about all the time we have for Q&A for WaterWatch. So we are going to turn back to hear our next pitch. And our next pitch will be Team Phoenix from Buhack Colony High School. And they will be pitching a campus cleaning robot that boosts cleanliness around a school campus using an automated robot as an extra pair of hands that can maximize cleaning while minimizing human intervention so students can focus on academics.
Hello, Project Invent. I'm Gino.
I'm Kyle.
I'm Shane.
And we're Team Phoenix from Beehive Colony High School. And this is our school campus cleaning robot. So the story behind our invention is that trash is a huge problem around school campuses around the nation. And it is becoming a problem for staff and students. So much food is wasted and so much is left on the ground. And it's just disgusting overall. So we were tasked with making a project that would help slow down the process, improve the situation a bit, or just completely stop the problem.
Some quotes that inspired us to do this are "Opportunities don't happen, you create them" by Mr. Alejandre, the department chairperson for the engineering part of the school. And then another quote by Henry Prosky is "Science is about knowing, engineering is about doing." And another quote by our janitor is "The way to get started is to quit talking and begin doing." And these quotes helped us and inspired us to keep going on and building this project.
This is our prototype for our campus cleaning robot. This will demonstrate how the claws will pick up items and deposit into the trash can above. The robot would use the arms and would use the gears to go in 360 degrees. The motors will allow it to open and close the claws. The robot will have sensors on them, like thermal sensors and camera sensors, to see and detect humans' trash. It will be safe for schools to use, so it will not hit students, and students can go on their daily lives.
So our reflection is our professional advisor and our passionate team believes that this will benefit our school and the U.S. because it will help pick up trash and it'll solve the trash problem at schools. But the way we gotta get started is at our school first, and then we'll help spread it throughout the U.S.
Thank you everybody for listening to our presentation. This is our lovely Team Phoenix team we have here at Beehive Colony. And before I end off, I have one more quote by Scott Bolesky. It's not about the ideas, it's about making them happen.
Awesome. And now we will turn it over to our judges for another 4 minutes of Q&A.
Yeah, hi team. So can you talk a little bit about who your community partner was or who you reached out to for guidance on what needed to be done, maybe within the school or whoever?
People we reached out to help us get an idea of what we should make is our janitors and our students and teachers all around the community. We were asking around, and they really think this is a beneficial idea that could really help them.
Great job, guys. Really good presentation. So it looks like you built the robot, at least in some form. Can you tell me a little bit about that process and what did you start out as engineers, or did you what did you learn along the way that got you to that kind of final prototype?
We learned that it is more difficult than what it seems to be an engineer. And as you saw in the video, I had a trash can in it. I had to donate my own trash can. So yeah, it just took a while. That's all I've learned, is that it takes a while and effort to really make something good. And that's basically it.
Could you guys share what was like the biggest unexpected obstacle that you ran into, and how did you overcome it?
Can you repeat the question?
Yeah, sorry. what was the biggest unexpected obstacle when you started working on this, and how did you overcome it?
One of the biggest obstacles was mainly just programming it, because we are trying to program it to tell the difference between actual trash and plastics too.
Where to?
So can you tell me a little bit about how you were thinking about how to actually go about maybe rolling out this technology? You talked a little bit about it at the end where you said you wanted to kind of start at your school. What schools do you think would find this most useful, and where would you start if you won some money to kind of build this and test it out?
We mainly think that outdoor schools would most benefit from this, because people will just find it okay to leave trash everywhere. And in more open schools, like here in Central Valley, you'll just see trash everywhere you go. So I definitely think we'll start in our little own Central Valley where we come from. Then we could probably branch out to more open schools like that.
Very nice. Thank you.
I think we have time for just one more question.
What part of this are you guys the most proud of?
Most proud of is just getting with the team to really help with this idea. That's what we're just most proud of.
Excellent.
All right, excellent. So that wraps up our Q&A with Team Phoenix. Round of applause. Next, we're going to watch the pitch video for Team NI2C. Their product is a walking stick add-on that alerts visually impaired people to hazards that exist above ground level. So let's see their pitch.
We are NI2C, and this is our team. I'm Zach Hirschon.
I'm Tony Wong.
I'm Luke Marino.
I'm Tim Huber.
I'm Matthew Lehman.
Our acronym is NI2C, which stands for Noise Imagery to Caution. So the problem that our device aims to aid with is the occasion in which a visually impaired person is walking using their walking stick, and they encounter an obstacle that is outside the detection range of that walking stick. So our device will work with that walking stick to further caution the user.
In our solution, we took an Arduino board, which is a microcomputer, and we connected it to a supersonic sensor, which senses how far away an obstacle is, and depending on how close it is or how far away it is, it'll either beep continuously when it's close, or beep with a little bit more time in between the beeps if it's further away, but still close enough to be a possible threat. This is a 3D render of our first concept design, which shows the exposed supersonic sensor. It has an adjustable angle, and the most important thing for our device is that it's able to clip onto any cane, so it works with anybody. So for our official 3D design, we incorporated all these elements, and we made it so that it integrates with a GoPro mount for a cane, so you can just clip it right onto there. Through some user testing, we have concluded that the buzzer can be felt very clearly through the handle of the cane, but we may have to tweak which distances the vibrator starts buzzing at.
Our two competitor metrics is the Smart Stick for Blind, which is built by the IEEE Maker project, and another competitor metric is WeWalk. For the Smart Stick for Blind, this stick comprises of a sensor and Bluetooth module to allow it to communicate with smartphones and make it efficient. And for this stick is also mainly made by Arduino project, and Arduino as the main controller. And it also shows as the Bluetooth interfere between the controller and smartphone. And another competitor matrix, WeWalk, is very expensive. It costs like nearly $600, and the biggest advantage of WeWalk is it have navigation function, and it also can discover the restaurants, shops, shopping malls around you, and you will get the feedback by the voice created by the WeWalk stick. And our project is called NI2C. It costs like $60 to make it, and we use Arduino as the controller, and the Arduino, like whether there is an object or distance of object will be expressed by the amplitude and frequency of vibration. And the advantage of NI2C, which is our project, is that it's light, easier to carry. For example, the WeWalk is very huge and big. It's hard to carry in a bag, but ours is good. And also it's convenient for those who have poor hearing because it's vibration, and it can also save energy because it only uses like small battery to work.
Next steps. Fit our prototype into the casing. It's going to be really easy. Ensure that the device easily attaches to all sorts of canes. Try to find other applications for the device. The end. Thank you.
All right. Thank you. So now we're going to turn it over to our judges for 4 minutes of questions and answers with NI2C.
Great job, team. Very impressive. I love that you guys had a full CAD model there, 3D printed parts. That's really great. What CAD software did you guys use?
So we just used the web version of SketchUp, which is kind of a grueling process. The models are great, but unfortunately we've had a bit of trouble 3D printing. So we haven't gotten a hands-on of the full prototype yet, but we're really close to that.
Great job, guys. I actually also I have a vision impairment. So I am very familiar with the problem that you outlined, and you definitely hit on one that is real, and that is often a problem. Can you tell me a little bit about how you engaged with members of the visually impaired community to develop this in such a way that it is really useful?
So we actually didn't really have any real engagement with the visually impaired. We couldn't really find anybody near us, or couldn't get a hold of anybody. But we actually did a project in class this fall where we tried to navigate campus while blind, just with a stick. And we had a lot of big takeaways from that, kind of how hard it is to not bump into stuff. And finding elevated surfaces and bumping into that was one of our bigger issues when we were in classrooms, because there's a lot of desks everywhere.
Okay.
What was the biggest issue that you ran into while you were working on this, like the hardest challenge you had to overcome?
So that, as I touched on before a little bit, it's definitely been 3D printing. Getting our initial code to work was kind of a challenge at the start, but that got fixed pretty quickly. It's just kind of iterating the different CAD models for our 3D print and trying to get that to work. It's been a huge challenge.
What kind of 3D printer are you guys using?
I think it's a MakerBot Replicator.
Okay. That explains why it's not working.
Yeah, it does actually. So can you tell me a little bit about how your goals for this project changed from the very beginning through to your final prototype?
So at the very start, our main goal was trying to figure out how we're going to integrate the Arduino with this. And really learning how to code with that and understanding how that all works. But once we figured that out, it really came down to designing the device in a way that actually fits everything we wanted to include. And then from there, we've spent probably way too much time trying to get a physical prototype in our hands. So I think that's about it.
I do have one more question that I like to ask of teams sometimes. So tell me about, I imagine at the very beginning you brainstormed a whole lot of ways that you could solve this problem. Tell me about the idea that you didn't build.
It was very similar to this one, although instead of a silent vibrating buzzer, it was going to have beeps. And it was also going to indicate with like colored lights how close something was. But we quickly kind of backed away from that because we thought that would be a little too flashy and draw a lot of attention towards it. So we decided to go for something a little bit more discreet.
Okay, awesome.
And that is the 4 minutes of Q&A. So thank you. And we're going to hear next about Upflow. Upflow is a product that filters out and makes combined sewage overflow systems environmentally friendly.
Every day when you think of a river, you think of something peaceful and tranquil and something to spend the rest of your day at. But in actuality, it's something that's used in every aspect of your life. It's used for drinking water, it's used for cleaning your clothes in some countries. But this is not the case for Fort Wayne, Indiana. They can't trust the rivers, and this is because of a major pollutant of CSOs, or combined sewer outflows.
Combined sewer outflows, or CSOs, are when the sewage from the houses and buildings go into the same pipe as the water runoff. So on a nice, normal, sunny day, everything works perfectly where the sewage just goes straight to the wastewater treatment plant. But when it's raining heavily, all the water from the rain goes into the pipe with the sewage, and the pipe can't handle it, so it has to have that discharge of pollutants into the nearby body of water, because if it didn't, then it would flood the streets and all the sewage would go back into the houses, which is not ideal. These are all problems our community partner Simon addressed to us. Simon is a stormwater consultant for the state of North Carolina. Simon helped us solve these problems with a multitude of other issues regarding the current sewer systems in cities across our state and in the U.S. The overflow of combined sewer systems struck our group as an immensely pressing issue, since such events would cause raw sewage to spill into the nearby environment. We want to tackle these issues head-on in order to reduce pollution in freshwater ecosystems and improve the health of humans and animals which interact with these ecosystems.
Hi, my name's Adam, and I worked with Davis, Grace, Udina, and Daniel to create Upflow and to address sewage problems across our city.
Implementing Upflow means that raw sewage will no longer be entering freshwater ecosystems untreated, which means no more eutrophication, no more increased turbidity, and no more bacterial pollution of these freshwater ecosystems, which will improve water quality as a result. This will be made possible through us putting Upflow at the end of a combined sewer outflow. Our invention will simply connect to the pipe where the water would typically come out. Upflow would go at the end of a combined sewer outflow in order to filter the water there. Looking at an overview of our system, you'll see that first we have an inertial separator which separates out solids from the liquid coming out of the combined sewer outflow based on their inertia. After the solids are separated out, the water which no longer has solids in it will go into a UV disinfection chamber where it will swirl in a vortex for a period of time, ensuring that the UV light can fully penetrate the water and kill most of the bacteria in this water. Taking a closer look at the inertial separator, you can see that there are some disturbances in the pipe before the pipe splits. These disturbances cause water to flow into one pipe while solids continue in their forward direction into the pipe directly in their path. The UV disinfection chamber is lined with very powerful UV lights, which will shine into the water as the water swirls in a vortex within this chamber, ensuring that all of the bacteria in this chamber is exposed to the light, and as a result, most of the bacteria will be killed by the UV light.
This is the prototype of the inertial separator part of our design. We're just going to pour some water in the top, and then it comes out both of the pipes. As you can see, all the junk is coming out of one pipe, while the other pipe puts out some much cleaner looking water. Then our UV tank is going to swirl the cleaner water around so that it is slowed down and spends a lot more time exposed to that UV light. When cities and communities are considering what to do with their combined sewer outfalls, they have many options. They could, of course, just do nothing, but this would be a huge mistake, as they would be polluting their water supply and endangering the lives of their citizens. They could also, as many cities have done, build an entirely new sewer system. This would be great for their water, but it would be far too expensive for most cities to afford. There are some other commercial products that are available, but they do not apply in the same areas as ours, or they are more expensive. Our product is the best mix of affordability, versatility, and efficiency.
Coming up with a singular price for our product is not possible, as it would greatly depend on the certain situation. We would have to work with governments to get a specific pricing. However, we do feel confident that it would be a fraction of the cost of other alternatives. The next step of our product is to start communicating with government facilities and universities to size our product up and make sure it works on a larger scale. With funding from you, you're hoping to reduce the effects sewage overflow has on the environment and contributing to a better world.
All right, awesome video. Next, we'll turn it over to judges for 4 minutes of Q&A with Upflow.
Yeah, this is a very ambitious project, guys, but this is it's a big task. Can you tell me if you ran into something while you were working on the design where you were kind of going in one direction, thought you had it figured out, and then something went sideways and you had to change and go to another way? Did that happen at all, and how did you guys solve that?
We experienced a few hiccups through our design. The first thing was we came up with the inertial separator part of our design, and we were thinking that we could just remove all the solids out of our wastewater and that would solve the problem. And then we realized that most of the issues in the water, the bacteria, and like pesticides and such, is actually not contained within solids. So just removing the solids would not nearly be enough. And so then we came up with our UV tank, and we had to add that on afterwards to solve the problem of bacteria, which was a major concern of ours.
I think you guys did an awesome job, and the idea to have the water swirl around for a little while in a vortex so that it spends a little bit more time around the UV light is very smart. Can you tell me how you would think about, sorry, there's some stuff going on outside. How would you think about making sure that the UV light continues to work and is staying on, and how would you kind of service your device if it were in a waterway?
So in order to make sure that the UV light is continuously working, we would implement a sensor on UV sensors opposite to the UV lights in the disinfection chamber, which would sense if the lights are on, and if for some reason they were to fail and thus turn off, this sensor would alert the proper authorities by simply just sending some sort of notification. And then in terms of servicing, this is a product that would need to be serviced likely once a year just to check in on how things are going generally. And it could be accessed through a simple manhole, since this would be underground. So you would need to have a sort of manhole that you just go down in and would service our device.
Awesome.
Did you guys do any simulations of how the water would flow through those tubes to ensure that it's doing what you think it's doing?
We didn't do any like digital simulations, but we ran a lot of tests with our physical model to ensure that we were getting the results that we wanted and that it wasn't just a fluke. And we did a good bit of research online to make sure that the physics made sense, at least in concept.
Awesome. Can you tell me a little bit about your kind of What was the most interesting thing that you think you learned going through this project? What was your favorite part?
So one of the interesting things is actually understanding what an inertial separator is, because going into this, the only other aspect that an inertial separator was used in is in airplanes. And of course, air is a lot different than water. So it was really interesting trying to get our product to actually work and make it function the way we wanted it to.
Awesome.
We've got time for about one more question.
I'm good. Rebecca, do you have another one?
I will ask you the same question as the other team. What was, when you were brainstorming solutions, what didn't you build, and why didn't you choose your other ideas?
So our main goal was to obviously filter the water that comes out of a combined sewer outflow. And it was very tempting to build a filtration system that had a screen, or it was even more tempting to stop this overflowing water at the source by implementing a garden in the sewer, which would sort of act like, I guess, an estuary of sorts, a mini estuary, where it would like act like a sponge, absorb the water to prevent flooding, and then slowly release it. But this just wasn't feasible due to all of the biological concerns, you could say, such as wildlife getting in the sewer and messing with this estuary and, stuff like that.
Awesome. That's really cool.
Thanks, Team EPFLA. And last but not least, we are going to hear from our last pitch, also from Athens Drive Magnet High School in Raleigh, North Carolina. This is Team Revivify with their product Flow Cycle that senses your soil humidity levels and your rainwater to revive your property and reduce stormwater runoff.
Hello everyone, we're Team Revivify. I'm Saeed.
I'm Chris. I'm Katie.
I'm Akul.
And I'm Tom.
Does this look familiar? Many of you might recognize this as your front lawn. How often would you say that you water your lawn? Once a week? Once a month? Or never? If you said never, you're not alone. Only 67% of Americans water their lawn, and a lower 10% water it consistently. Although not watering your lawn may seem like a minuscule thing, this is what it can lead to. Weak, dry, damaged soil becomes hydrophobic. You may have only thought of things such as roads and maybe a roof as impermeable surfaces, but not watering your lawn can turn it into one as well. Runoff from the soil leads to the flooding that you see presented, and oftentimes it leads to flooding of sewer systems that are not capable of handling these immense amounts of water.
And the person who introduced us to this problem, our partner, is Simon Warren, who's a stormwater financial consultant. He deals with stormwater and also helping people with their financial side of things, which we were not able to help with as much, so we focused mainly on the stormwater aspect, which led us to creating our product.
Flow Cycle is a drip irrigation system built to help get rid of those dry, hydrophobic spots on your lawn, while also helping to lower your water bill. It consists of a barrel, water pump, drip irrigation piping, and a soil moisture sensor. As it rains, the water will flow off the roof by using the rain gutter and into the barrel where it will be stored for later use. The soil moisture sensors will measure when the soil's moisture drops below a certain level and will trigger the pump to begin pushing water through the pipes. The water will continue to flow to the soil until the soil moisture has recognized that the soil has had enough water, and it will stop.
To show you how our product works, we have this demo of our works like. So first, the moisture sensor detects that there's low water in the soil, and it turns the pump on, which starts to hydrate the soil. Eventually, the moisture sensor detects that there's enough water in the soil, and so it turns the pump off and water flow stops.
The best feature of the Flow Cycle is the fact that it's automatic. As a result, it's very user-friendly, as the only thing the user has to do is change the filter every few months and set it up. Additionally, it's very environmentally conscious, as it saves water by capturing it and then only irrigating when needed.
After meeting with experts in different fields, we began to change our idea. It went from a small portable version to something that can be placed under your roof and collects rainwater from that. It's a larger version, which means that it can water more lawn, and this makes it more automatic and efficient for the user to use.
And now for our competitor matrix. Some of our competitors include Raindrip, Irrigatia, and Rainbird, with Rainbird being our primary competitor out of these because it has a similar price point and aims to do a similar thing. As you can see, we have a quite high effectiveness because while most of our competitors run on a timer-based system, we only run when the soil needs it. Our portability is a bit lower though, because we use a 500-gallon tank, which is quite heavy. We're able to conserve water quite efficiently though, because we only run when the soil needs it, and instead of pumping water from your house, we collect water from your gutters, and we're able to reuse it. Our convenience is also quite high, because you don't have to do anything. You just set it up, and then it'll run on its own. Our setup is also quite efficient, because while most of our competitors have to be put in during construction, for us, you only need to put it under the gutter, and then you put pipes above ground, and it'll water it like that.
And here we have split up our pricing into two different graphs, as you can see. One graph containing the 500-gallon rain barrel cost and the other one not containing it. The reason behind this is because some homes and businesses already have rain barrels and cisterns installed. So we have a separate graph made for those people who do not need to buy the 500-gallon rain barrel.
And for our next steps, we will need to create a full-scale working version of our design that can be implemented into everyday life. We will need to research and configure methods to release a free soil testing kit that could be delivered alongside our product, as different amounts of soil need different amounts of water. Lastly, we will need to find a way to develop our product so that it could be used in areas that have less buildings and cannot get rain off of the buildings.
The biggest and most important question is, how will the flow cycle result in a better world? First of all, it'll increase the water supply. Instead of using water from pipes to maintain your soil and lawn, you'll use water that's caught directly from the rain, which is at no cost to you. Second of all, it'll reduce erosion in local stream banks and rivers because there'll be less runoff. Third of all, there will be less chemicals that get picked off the ground by the rain, which means there will be less chemicals in local ecosystems, which will lead to a healthier environment. And lastly, there will be less floods as a whole, hopefully leading to less devastation.
And now we wanted to give a special thank you to Miss Luna, our teacher, Simon Warren, our partner, Jenny Shee, the one who helped us with our presentation, and Mitch Woodward, who helped us with research.
So another awesome video, and we will now turn it over to judges for our last 4-minute Q&A.
Yeah, hi team. This is very impressive. I completely coincidentally, I just purchased a product very similar to this for my garden. So I just got done researching all this over the last couple months. So I guess that's good timing. I'm curious, you noted in there that part of what you were doing was capturing rainwater. Did you work with your community partner on what the regulations were in your area about capturing rainwater?
Okay, so for actually our financial consultant, like we said, he does something more with stormwater. So we reached out more with other people, and we actually ended up talking to Mitch Woodward, which is how we got the idea to use rainwater as opposed to using something like stormwater or gray water, which would have a bunch of different other side effects.
Right, okay.
So it looks like your product uses sensors to tell when the soil is full of water or saturated. How do you have to think about where those sensors are placed so that, you know, water doesn't pour immediately out of the tube and onto the sensor, and then the sensor thinks that, you know, obviously it's plenty wet, and then turns the system off? Where do those sensors need to be placed strategically so that doesn't happen?
Generally about 8 to 12 inches away from any piping, because the range of the pipe would be about that. That way the sensor would only pick up the moisture once it's reached over there, which is as far as it would go.
Awesome.
Did you guys consider also integrating this with live weather feed data? Like, for example, if the system knew that there was a storm coming and it was going to rain, like later that evening, then obviously it could wait and not water the lawn because it knows rain's coming. Did you guys think about that type of stuff at all?
That was one of our original designs, but the thing is that would require a lot more electronic wear, and it would require the user to set it up more. It would require constant Wi-Fi, stuff like that. So we decided that a moisture sensor might be better suited to that. And then a moisture sensor in tandem with our next steps, which would be a soil kit, so that we could ideally like tailor it specific to your soil. I feel like that would accomplish a similar thing. It might even be more accurate, and it would require less.
Did you think about embedding the tubes under somebody's lawn so that just by way of osmosis, the water kind of comes out and into the system and then you don't need the sensors?
So we were actually looking into subsidized irrigation, which are becoming more and more popular. But the only thing is, the drawback with that is that it is more on the people who can't afford it, and it's more expensive to like dig up a lawn. And that was with one of our competitors. And so we didn't want to go that path. We wanted it to be more affordable and for other people, for other users.
That makes sense.
And for about one more question.
Go, Rebecca, use your last question. That's a good one.
Okay, we like this question. Yeah, tell us about what you didn't build.
Okay, so he's bringing up our old, because we changed a lot actually. So this is our old design, and as you were talking about, it goes into the actual area, and so this is a pipe, it would go into the actual lawn and it would disperse water like that. And then we moved on to like this design where we were building, and this is where we got. Originally it was laying all over the lawn instead of tailored designs. And so we have slowly, and also this was originally portable, so it was away from the house. So we actually changed completely after talking to Mitch Woodward, and he told us that the water would be, we can't go something 55 gallons because it's not going to function properly. It won't water a huge lawn that most Americans might have and use this for. So instead we had to go, instead of going from mobile, we had to actually move it to stationary and get a 500-gallon tank that would collect the water and stay there.
Awesome.
Awesome. Yeah, loving all of these prototypes of ideas that weren't built. These are super cool. It's an extra treat. That wraps up our pitches. So congrats to all of our brilliant student teams and to everyone who helped to support them to get them to this point with their network of teachers, mentors, and family. Our panelists, our judges, are now going to head off into another room where they'll take about 30 minutes to deliberate and decide on our 2 awards. And the rest of us are now in for a treat with our keynote speaker, followed by some highlights from each of our teams. We're lucky this evening to have our keynote is Stephanie Farsht. She's adjunct lecturer in entrepreneurship at Northwestern University in Kellogg School. Stephanie is a strategist and innovator who spent 16 years at Target Corporation developing what's next in omni-channel Target. Her focus is on driving new businesses and strategies that leverage innovative technology. Stephanie led and managed teams charged with evaluating acquisitions, joint ventures, partnership opportunities, and developing relationships with key digital partners, VCs, and early-stage startups. She initiated and executed numerous high-profile test and learn strategies focused on emerging business models such as flexible fulfillment, loyalty, and alternative payments. Please welcome Stephanie. The floor is yours, and I'll pass over screen sharing.
Thank you. Thanks, everyone. Can you hear me? Awesome. Okay, let me test one quick thing before we get going. Hold on one second. Can you guys see my notes, or are you just seeing the screen?
We can see your notes.
You can. Okay. I had a feeling that would not work. Okay, no worries. We'll just do it the normal way. Okay. I know you guys have been on Zoom already for quite a long time, so I'm going to try to keep this quick and fast and high energy so we can not fall asleep on Zoom. So thanks for having me. It's been fun listening to these pitches. You guys are doing amazing. I could never have done this at your age. And I teach a very similar class to what you guys have done this entire year at Northwestern. So it's kind of fun to see the comparisons and what you've built. And I would say a lot of times you guys might be exceeding what our students are building. So you should feel good. When Project Invent asked me to do the keynote today, they asked me to cover 3 key topics: curiosity, resilience, and ambition. And all of these seemed really straightforward enough to talk about until I sat down to write this and realized I was stuck. My example seemed kind of superficial until I realized that there's one common thread that weaves through these 3 important characteristics, and it's failure. Yes, failure. Seems like a strange thing to put over those 3 things. It seems counterintuitive, but failure is the common thread for me that weaves through curiosity, resilience, and ambition. It's through our failures where we truly learn and grow. And you have to actually be comfortable enough to fail in order to be curious, resilient, and ambitious. From my experience, the highly successful people are the ones who have failed the most. As I mentioned, I've been a professor for the past 8 years teaching as an adjunct at Northwestern, a class that's very, very similar to what you guys have done this year at Project Invent. The number one thing my graduate students who are usually 27, 28 years old are telling me they're most afraid of is failing. And I'm not talking about getting an F in my class. We usually only give A's and B's. In fact, we're only allowed to give A's and B's. So there's no failing. I'm talking about testing and learning. So they're building projects, they're doing MVPs like you, and they're so terrified of making mistakes while they build these projects. Even asking questions that aren't exactly right is something that they're very afraid of. They're downright terrified to fail. And most of them have never failed before. They're at a top business school and they've been successful and they've been in an environment where failing is really not an option. You may be wondering why I'm showing one of SpaceX explosions when they first started launching rockets into space. From our perspective, you don't get people to Mars without blowing a few rockets up along the way, maybe even more than a few. So these are all some of the dates of when the explosions have happened. And I think, I didn't look, but I think there's a new explosion that just happened this year. I think it may have been a couple of weeks ago. Failure is not something to be feared, but it's actually something to be embraced because each failure brings us closer to the right solution. And I'm sure Elon Musk is thinking that at SpaceX as well. So I changed the agenda that Lee gave me. I'll walk us through a couple of examples that show how failure actually reinforced all three of these characteristics that are near and dear to my heart. There's curiosity through failure, there's resilience despite failure, and there's ambition because of failure. Two examples will be from my startup called Small Wonder, and I'll walk you through that in a second. And then one example is from my early days of teaching at Northwestern. Okay, everybody can still hear me? Good? Okay, awesome. Okay, by the way, does fail actually mean fail? I saw a really fun meme recently and it kind of struck me and stuck with me. Failure is not actually meaning failing. It means something to be put in context of learning. It's first attempt in learning. It's not something to be feared or avoided, but it's rather embraced again and again. So it's a good way to think about it. So let's start with our first characteristic that Project Invent wanted me to talk about, curiosity, but I'm talking about curiosity through failure example. So we set out to build a company 3 years ago, and we kept seeing this company early in its first couple of weeks in launch called Blue Land. They were on Shark Tank, if any of you guys watch Shark Tank. And what they had done is they had created a concentrate tablet to put in your forever beautiful bottle at home. So they no longer needed to ship you big bottles of hand soap, Windex to clean your windows, bathroom cleaner, whatever it may be. You would just drop a tablet in, you would add water that you have at home, and voila, you would have a new bottle of hand soap, window washing fluid, or whatever you needed to do your cleaning. And so we felt that there was no one doing this in the hair care space or in the shower space. You have a ton of water in the shower, yet we're buying these really large bottles of shampoo that are 85% water, conditioner 70% water, body wash is 95% water, and bubble bath is actually 99% water. And we felt this is a great business to start. We need to actually go solve this problem. But to be honest, we felt a little bit in over our heads. We started reaching out to different chemists, cosmetic chemists, subject matter experts. And these are the answers. I actually went back to my DMs because we did a lot of this through Instagram. We went back to the, we reached out to these subject matter experts. We started getting these responses. Doors kept closing, yet we kept getting more curious, but we kept getting really, really tough responses back. The more doors that kept closing, the more we were confused as to why no one felt like this was just really, really logical. No one had actually innovated in the shower for the past 50 years. So we got these responses. They were tough. We started feeling a little bit like imposters. We're like, why do we have any business starting a company in the hair care space? We've never done hair care. We're not chemists. We have no experience in this. And imposter syndrome started to creep up. And if many of you have never heard of imposter syndrome, it basically thrives on the idea that we should have all the answers. We should instantly and effortlessly know everything. And here's the truth. Nobody has this figured out. And the longer I've spent time building out my career, the more I realize and the more I know that I love not knowing things. It gives me the freedom to ask. It gives me the freedom to be naive and actually explore and ask why, and why. So I kept exploring. And I know this is a long text, you don't have to read through it, but this was the golden text. I think we had 10 or 12 really bad conversations. And then I boldly texted or DM'd a woman that was called Cosmetic Chemist on DM or on Instagram and said, is there any chance we could talk to you about creating some type of dehydrated format for shampoo and conditioner? And she said, absolutely. And the rest was history. 3 years later, we actually have launched Small Wonder. It's called, it's the only salon formulated powder to foam shampoo, conditioner, body wash, and shaving cream business so far. It's launching in about 2 or 3 weeks, and it has been a long, long journey. So back to curiosity. It ended up helping us. It ended up taking us through our failures and spark more and more curiosity as we learned about some of the challenges and the roadblocks. It's the need to explore, it's the need to question, it's the need to seek answers. And when we ran into these obstacles or roadblocks, our curiosity actually compelled us to dig a little bit deeper, to understand why things weren't going the way they were planned, and to actually uncover more insights, which got us to this innovation. It became the catalyst for curiosity, propelling us to actually innovate. So that's my first example for the first characteristic, which is curiosity. And this is something that I keep in my head often. If you aren't in over your head, how do you know how tall you are? It's kind of a cheesy comment, a cheesy quote, but it's actually something you should always think about. You don't know how far you can go unless you've actually pushed yourself. Okay, second characteristic, resilience. Resilience despite failure. It sounds great. Resilience sounds wonderful. It actually feels really crappy when you have a setback. It's pretty awful. We had our powder ready to go. We had tested it with a ton of different people. We felt like we had to move fast. This was really exciting. And so we quickly figured out that maybe a salt shaker concept would be a great bottle in the shower. So you're pouring out the powder in the shower on your wet hands and you're activating in your hands, and voila, you have this amazing shampoo. So we're like, a salt shaker is brilliant. Let's brand it and make them look really beautiful. We tested them with a few people. Everybody thought it was beautiful. Great, let's move. So we started doing professional photos. We built our website. A couple days later, after that test group had more time with those bottles, after we had bought 10,000 bottles and had shipped them from China and they were on the way, they started sending us pictures like this. The powder was clumping. There was enough humidity in the shower, maybe on day 8 or day 9, beyond our initial test with these bottles, where the powder couldn't get through. And they were starting to say, this is actually a really frustrating experience. It's awful. There's no powder coming out. I give up. The bottles were on the way. We'd already paid for them. They were now useless. So we mustered up some resilience. We pretended it didn't feel terrible, even though it really did feel pretty terrible. And we adapted. We found these bottles on eBay. We tested them in every possible scenario. We postponed our launch. We asked others to test them. And we bought as many as we could to start over. It was the biggest amount of money we've lost to date. We've created a ton of waste, which was the reason we started this company, because now there are 10,000 bottles that need to get recycled, but we moved forward. And the best part of this resilience is that it forced us to dig a little bit deeper. It forced us to ask more questions, and we determined that we actually needed to design an amazing bottle for this experience. We hired an industrial design firm very quickly. 3 months later, we've now created this bottle called Flare, where you basically have the powder inside, you press down on your hand, so no water or humidity is going in, and you get a perfect amount of powder sprayed on your hand, you activate, and then you have this wonderful shampoo experience. We would have never created our own bottle if we had not failed with that first bottle. So it really did push us to actually innovate and do better. So that was our resilience experience. Third is ambition. Ambition because of failure. This is a tough one to swallow, and I'm not going to pretend it's easy. So I've been teaching at the university for the past 8 years on and off. The first 4 years were going great, and I don't know if you can all see this. Let me move. I have to move my. There we go. Okay. This was me. This was our score back from our students, a very important score when you're a professor. It's really the only grade you get back. How do the students feel about you? And this was the rest of the professors at my university, in my department, and the rest of the broader university. I was crushing it. I'm like, oh my gosh, this is my first year. This is great. The students like me. Thought it was great. Next semester, did even better. Kept kind of widening that gap a little bit between me and the average. Thought I was really, really doing great. Very, very excited. Third year, same thing. Really, really great reviews. I was starting to get really bored. I'm like, I don't want to make changes because it's not broken, but this is actually starting to get a little bit repetitive, even though the students don't know that because there's new students every year. So I decided I need to actually overhaul the class. There's all this feedback that I kept hearing about from my students throughout those years and throughout those semesters. And I was just too afraid to make the change. I was so afraid of rocking the boat. I finally jumped in and said, let's overhaul the class. Let's make major changes. And I bombed it. I bombed it so badly that I actually ended up being below the average and got put on probation. So if you get below what we call a 4.5 out of 6.0, you get one more semester to fix it. And if you have 2 semesters in a row below this line, you're out. And I was absolutely crushed. Couldn't believe that I was now in this situation. It felt really bad. I felt like I'd failed. I moped around for a few weeks. I felt like giving up on teaching. But then something happened. My ambition kicked in. It was not quick. I can't make this sound easy. But I suddenly wanted to do my best. I felt like if I was going to quit teaching, I needed to go out on the top, not go out on the bottom. I had too many good semesters behind me to go out at this very low level. And so I worked so hard over that break. And I decided I needed to do my best. And what happened? My ambition really took over, which is the driving force behind any meaningful change. It gives you the motivation to dream big and push those boundaries. And I realized that I really didn't fail. I did my first attempt in learning and I applied that to make it even better. And my final score was better than I'd ever done. I ended up staying another 1.5 years after that, mostly because of COVID and the needs that the school had, but I was gonna go out on top and I stayed on top, not as on top as that semester. But that reworked curriculum really, really was pulled from that tough semester. I learned more from that tough semester than any of the prior semesters that I had taught. Got my best score ever and ended up being one of the top profs in my department. So my parting words, this is kind of a mixture of quotes and things to think about as you move forward in your career. Sometimes the only thing that's holding you back is what's in your mind. So obviously this horse could pull the very, very light chair that it's attached to if it really wanted to. Embrace failure, use it as a guide, and know that we need to fail, test ourselves to fail every single year, every single semester. Start asking yourself when you last failed, and I think you'll have a really tough time finding an example. So good luck, everybody.
Thank you so much, Stephanie. I especially appreciate how you modeled vulnerability there with that last example. And because we're going into student reflections next, I think that's a really wonderful example to set for students as they reflect on their projects in the next upcoming segment of this evening, and then as they go forward into their lives as inventors and innovators. So on that note, I'd like to turn it over to our student teams to share about their journey with Project Invent this year. We'll spend the next 10 or so minutes learning about our students' experiences, their first attempts in learning. And they're going to answer 2 questions. Each team will answer what was a significant challenge that you experienced while designing your product, and what helped you remain resilient, or what motivated you when you experienced those challenges. And this is a brief and informal reflection. We'll go team by team, and each team will have about a minute to answer those 2 questions. So first up, we'll hear from Water Watch. Looks like they're ready. And we'd love to hear more about your year with Project Invent. What was a significant challenge you experienced designing your product, and what helped you remain resilient, or what motivated you when you experienced those challenges?
So we actually only had we only had Project Invent for about a semester, and it was the late semester. So while we were working on putting together our pitch video, that actually really coincided with the scheduling for AP exams. So we were scrambling at the last minute to get our video submitted and turned in, and our pitch coach or our teacher, our teacher helped us out a ton, and she pulled through for the rest of us. And the one thing that kept us all going, instead of just throwing in the towel, was every day we'd come and we'd hang out and talk like friends. And I guess none of us wanted to let each other down.
Awesome. Anything anybody else would like to add to that?
I think it was just a really fun experience. You get put into a class that you might not meet these people in any other class. I think I've had one class with Jack and none with Liz and Corey. And so it was a really good way to meet a lot of really cool people and do a lot of really cool new things.
Definitely. And like even between groups, we're very supportive of each other. So I love that.
Love that. Next up would be Team Phoenix, but I believe that they had to go catch a bus. Team Phoenix. I love Revivify is cheering for their sister team. So next up, we'll hear from Team Salisbury. Team Salisbury, are you ready? So yeah, if you could tell us a little bit more about your year with Project Invent. What was a significant challenge you experienced and what helped you remain resilient and what motivated you?
Sure. So I think our experience with Project Invent really, we owe a lot to our community partner. She's great, Crystal Bailey. She gave us a lot of insight and she does a lot for the community. And we really wanted to take one of the aspects that she focuses on and really drive home that point with assisting the visually impaired. And with that, there did come some challenges with the device we made, namely our pitch coach mentioned it might be worth it to do some more testing as far as battery life goes. So we did that. And then running into the challenges we've had with 3D printing, but I'm really proud of the way the guys kind of banded together and the way everybody found something that they could really focus on and contribute individually to the team.
Awesome, thank you. Next up, let's hear from Upflow. So what was a challenge you experienced and what helped you remain resilient, Upflow?
So one of the challenges that we faced was trying to come up with our initial idea of our product. And because if you don't remember, our product dealt with the sewer system, and we had to figure out how a sewer system worked and how to implement our product into it. And then one thing that helped us to remain resilient was the community that this class brought. We'd come into the class every morning and we'd see these faces, these friendly faces that we know we could just talk to every day.
Anything anyone would like to add from your team?
I'd also say like our teacher, Miss Luna, she was very supportive and helpful. Like she was doing everything she could. She gave us like lots of like research links and all sorts of things. She was like very helpful in like helping us get like roundabout knowledge of how sewer systems work. And the community like we built here, to add on to what Adam said, it was very supportive and very nice. Like we were all helping each other out. It wasn't very competitive at all.
That's great. Love the teacher shout outs too. And last but not least, from your same program, let's hear from Revivify. What was a challenge you experienced and what helped you all stay motivated?
Well, I'd say one of the biggest challenges to start out that we faced was actually just trying to work together and like come up with an idea that we all liked, because at first it was mostly us just like coming up with our own ideas and trying to like stick with all of them. But I guess one day we just decided, we came to like a complete compromise and came with an idea that we all liked. And so that was a challenge that we overcame by, I guess, eventually coming together and compromising.
And what helped us remain resilient the most, I would say, is our teacher. And Miss Luna was very supportive. She gave us all the resources we need. Probably one of the most important things we needed as a group was resources. And like she bought materials for us. She had us confer with experts. It was all done in a very timely manner. And it was very, it was not strict at all. It was a very carefree environment.
And just adding on to that, she like never got frustrated with us when we asked her and bombarded her with like a lot of questions. Even though she was dealing with all the other groups, she still was there supporting us like the best she possibly could, every other group. So we're just really grateful for all the effort that she's put in for our group to come to where it is now.
Love that. And I love that you called out how hard compromise can be as a challenge, because I think that's probably something that a lot of groups can relate to. All right, so we have a little bit more time before our judges are going to come back, which is great because it gives us a chance to hear from each of our teams again. We'll keep the same order. And this time we're hoping you can share just a little bit about what are you excited to do next with your product? Where do you think it might be used? If, let's say you have $500 and you get to build a new version, would you like to take it next? And we'll pass to Water Watch first, but if they need a minute of think time or to conference a little bit, that's okay.
Yeah, we might need a minute because a second transformer just blew at our school.
Oh, no.
That was that big loud boom. So they're trying to connect right now. I think, yeah, they're okay. Yeah, they'll be there.
Okay. Well, yeah, you can take a minute to think and get your internet. For anyone who didn't hear, the teams from that school are in a school without power, but still managing to connect professionally. So they get a shout out for that. Upflow, are you here and ready? Or should we pass to Salisbury first? You're pretty ready? Okay. So the question again was, what are you thinking about doing next with your product? Where would you like to take it? What other features might you want to add? Where would you be interested in investing and continuing to grow it?
So our next step would most likely be to test this out in like a larger scale corporation. So we originally tested our like inertial separator with small PVC pipes, and those aren't exactly the most accurate to like what an actual sewer pipe size is. Like most sewer pipes are like around like 25 feet. So we would like to test it in a larger scale corporation to see if the physics would work. And we'd also like to get more money for like funding to like have this implemented in those larger scale corporations.
Great. How about Team Salisbury? What are you interested in your next steps?
So I think for our next step, the biggest focus right now is to really create that adequate housing for our product. And once we are able to get that squared away, whether that's 3D printing or some other method, we should really focus on getting some enhanced testing with the visually impaired person, so that with that we could get some really more adequate feedback from the demographic that would benefit the most from our product.
Great, thank you. Let's see. Oh, I started with Upflow and I should have started with Water Watch. My apologies. Let's hear from Revivify and then Water Watch. Or we got Water Watch highlighted. Let's hear from Water Watch. This is my bad. Thank you. I appreciate the flexibility.
Could you repeat the question? I'm sorry.
Not at all. So the question was, what are you looking forward to doing next with your product? Are there features you're looking forward to adding? If you've got a $500 to invest in it and think about what comes next, where would you like to take it? What would you like to add?
So we would really love to test for more contaminants. Like one of the things that Addison and I were looking at as we were researching this was arsenic, which is a really big problem, especially for well users. We would love to be able to contain and repeat the testing for that, as well as like Teflon and PFAs, which are really dangerous.
I personally would absolutely love to be able to finish a bunch of the internal electronic components, because I was under a bit of a self-imposed time crunch. And I honestly, it still kind of annoys me right now that I didn't get to finish it to how much I wanted it to be finished.
Appreciate that honesty. And last but not least, Team Revivify, what are you looking to add next and grow in your product?
Okay, so our first step in the future is going to be creating a full-scale working model with an actual 500-gallon rain barrel, because that's something that we just do not have right now. And after that, even further in the future, our main goal would be to create a version of our product that is not as dependent on being near buildings, because right now, one of the biggest limitations that we have, and one of the things that we didn't really want to be limited by, is having to be near buildings to receive this water flow that's necessary to irrigate lawns and soil. And so in the future, we would definitely add features that allow our barrel to be placed far away.
Awesome. Yeah, thank you all for adding all those extra visions for the future. I hope we all get a chance to maybe enact some of those next year as you keep going forward. We are going to go ahead and start talking about our awards, not exactly who's getting them yet, but a little bit about what the awards that will be awarded tonight are and why we've chosen those awards to celebrate a couple of teams tonight. So the awards tonight are based on the student mindsets that you've been looking at this whole year or this whole semester with Project Invent. So they're really based on how the judges see teams growing across those different mindsets during the design thinking process. And so as a reminder, and for our guests who haven't been immersed in this, those mindsets are ambition. So we heard the judges a couple of times say, whoa, that's a really ambitious project. You're tackling a big issue. So ambition in setting high goals. Agency, learning independently, asking for those resources, taking those resources, and rolling with them as a team to build and problem solve and grow together. Creative confidence, taking an innovative approach, building something that you can't just go out and see in the store, on the street, something that's really new. Empathy, listening to your users, to your clients, to your community partners, and really listening and putting yourself in their shoes and seeing what they're saying rather than what you're assuming you're saying. Resilience, we already heard a really great talk about that tonight. Learning from failure, getting up and growing again, making it work when you've ordered 10,000 bottles that turns out won't work for your product, etc. And curiosity, growing, looking, trying to wonder how do things work, what can we do, asking all those questions that are always absolutely a good thing. So the two awards that we'll be giving tonight are based on, I need to reshare my slides, but we'll be giving the Product Pivot and Explorer Awards. No, we'll be giving the Product Pivot and Moonshot Awards tonight. So the Product Pivot is for a team that overcame many obstacles, and the Moonshot Award is for an especially novel and impactful idea. I'm going to stop sharing for a moment to reset my slides and maybe turn it over to Lee for a minute while I do that.
Awesome. Thank you, Hallie. Our judges are back, so we are ready for them to announce the award winners if you guys are ready to announce them.
Yeah, I think we're ready.
We are ready.
Awesome. Well, we'll turn the floor over to you guys to announce, and then Hallie will take it after announcements. We're excited.
All right, sounds good. Well, I'll go first. I'm going to present the Moonshot Award, and then Rebecca's going to do Product Pivot. So I'm just pulling back my notes here. So first of all, before we go through this, I just wanted to thank all the teams. We were both very impressed. You did not make it easy on us. We actually spent quite a bit of time diving deep, trying to figure out how to tease the teams apart. And really very, very impressive work by all the teams. So with that in mind, for the Moonshot Award, we went with Water Watch. We felt like that was a very ambitious project. We really liked kind of the novel approach on how to solve the problem. I was sharing with Rebecca that when I purchased my current home, we were unable to get a loan from the bank because we were on a well water system, and the water was contaminated and the bank wouldn't do a loan. And we had to jump through quite a few hoops to come up with a solution that would qualify the water to be able to get a loan. And so I have some knowledge about this, and this solution is we felt like it was, a novel approach to doing it, and would be very impactful. So congratulations to Water Watch for the Moonshot Award.
Thank you all so much.
Okay, and I am going to present the Product Pivot Award. Again, I have very much the same feelings. I was very impressed. I was not doing any engineering to any of this extent until I was in college, probably actually a couple of years into college. So super impressed that you guys are just in high school and already doing all of this kind of stuff. This was, I think, the most difficult award for us to choose. We felt like all of the teams had a lot of obstacles that they had overcome and really were taking a lot of factors into consideration and learning about their problem as they were going and making shifts. Ultimately, we did decide that the Product Pivot Award would go to Team Flow Cycle. We're really excited by your product, and we think that you have a really great plan to continue building it and to actually to implement it at a full scale. So congratulations to Team Flow Cycle.
Thank you so
Thank you
much.
very
Seriously,
much.
thank you.
It's great.
All right, so big congrats again to our teams. It's going to bring us to wrapping up. I'm sorry, I have slide troubles, but I'm going to just go ahead. So congratulations again to Flow Cycle and WaterWatch and to all of our amazing teams today. Also a huge thank you to our panelists, our keynote, and our sponsor ThoughtSpot, our audience and donors, and to everyone who helped these teams along the journey, from teachers to mentors to family. You can continue to donate to Project Invent to enable us to continue this mission and empower young people to innovate all year round. And with that, I just wanted to thank everyone again, and I'm going to pass it to Lee for a last few words.
Yeah, everyone, we want to say just a huge congratulations. You all did incredible. We were blown away, just like the judges have been saying, with the incredible innovations, the passion you all have for solving significant challenges in the communities around you and the broader world. So we greatly appreciate students, you taking the time out of your year to spend with Project Invent. And teachers, we really appreciate you for co-learning and guiding these incredible students. We cannot do what we do here at Project Invent without our incredible teachers and volunteers. So volunteers like our judges and our fabulous keynote speaker. Project Invent gets the joy to be able to work with such talented professionals like you all. And we want to thank you for taking the time to invest in our students. So students, I hope you celebrate the incredible things you have learned this year. Truly, you're an inspiration to us all, and thank you for letting us celebrate you today. And with that, I'll go ahead and end our webinar, and we'll be sure to share out the recording so you can share it with your friends and family. Thank you all for joining us.